Hello friends, welcome to my channel. Let's have a look at problem 792, number of matching subsequences. So this problem is a daily challenge problem. So in this video, we're going to share a method based on word counts and the find method of a string. So this problem asks us to judge for a given reference string S and a list of words. How many words in the list are subsequences of the given string S. For example, in example 1, the return is 3 because A, ACD, and ACE are subsequences of the given string S. And in example 2, there are 2 words are subsequences of the given string S. So let's also look at the constraints about the S and words list. So S has a length between 1 and 5 times 10 to the power 4, and this number is a decent large number. And the list of words has a length between 1 and 5,000, and each word has a length between 1 and 50. So those are the main constraints about the problem. So now let's look at the method. So here the solution is based on word counts and the strings find method. So the idea is the following. First, if a word appears multiple times in words list, then we just need to check once to see if it's a subsequence of S or not. And secondly, we need to effectively check if one string is a subsequence of another string. So our plan here is the following. So we want to demonstrate the use of the find method of a string to solve this problem at hand. And then also, as an extra, we'll write another subsequence checker function for other possible use cases, but not here. So with that said, let's look at the code. First, I'm going to do the word count. So step 1, word count. So for this, I'm going to initialize a word count dictionary. So initially empty. Then we are going to traverse the words list. So for word in words. Then I'm going to increment the frequency of word in the word count by 1. So word count on word. So first we need to check if the word is already in the word count. So I'm going to use the get method to see if the word is already in the dictionary. Otherwise, I'm going to set the frequency to be 0. Then I'm going to increment this by 1. So this way we finished the word count. Next is a hyperfunction which basically judges if a word is a subsequence of the given string S. So let's see, check subsequence. So here I'm going to demonstrate the use of the strings find method. So in order to make it modularized, I'm going to write a function here. So is subsequence. So it accepts 2 arguments. One is S and one string, and another is a word, another string. So we want to return if the word is a subsequence of S. So basically, I want to first initialize the start index, that is 0. Then I'm going to do character matching. So for character in word. Then we want to see if we can match the character in words in the increasing index order. So let's see. I'll redefine the state of I by S find the character. So starting from a previous index I. And then I'm going to add this one by 1. So here notice that the strings S find for character I, if we cannot match the character in this string, then we're going to return the find method going to return -1. So if there's no match, then this whole expression will be 0, right? So then we are going to make a check if not I. In other words, I equals 0. So we didn't find a match. So we're going to return false. So otherwise, if we find matches for all the character in order, then we're going to return true. So this is the hyperfunction we're going to use to determine the final counts. So with that done, now let's do the last step, count and return. So this is actually routine now. First, let's initialize a result variable, making the counts. Then we're going to check all the keys. So for word, in word count. Then let's check using this isSubsequence function to see if the current key is a subsequence of S. So if isSubsequence S and word. If so, we are going to increment the result by the corresponding frequency of the current word or the current key. That is word count word. So that's all about this solution. We can return the final state of the result. So with that said, let's first do a special case check. It passes example 1. Now let's do a generic case check. So it passes all the generic case. It's fast. And that's about one format of solution. So in this solution, we split the code into 3 parts. In the first part, it's a word count. And in the second part, in order to make the logic clear, we wrote a subsequence checker function. So finally, we do the count and return the final result. So that's about it for a solution to the current problem at hand. So as specified in our plan, we also want to write another function which is going to check the if a string is a subsequence of another one from scratch. So let me write here just for the possibility of uses in other situations. So subsequence checker. So I'm going to define this function as check subsequence. So it accepts 2 arguments. Let's call it s, and another string, also call it word. So basically, it returns if word is a subsequence of s. So here we want to make a very brute force check, but it's also on the air. So I'm going to initialize ij to be 0 and 0, and let's call m and n equals the length of s and length of word. What we want to do is that we try to match the characters in word with those in s with increasing indices, so that we can judge if word is a subsequence of s. So basically it's a while loop, while I less than m and j less than m. What we want to do is that check if there's a match. So si, if si equals word j. If this is the case, it means we matched the character at index j. So then we're going to increment I and j simultaneously. So I plus 1 and j plus 1. Otherwise, it says that the current character I in the string s does not match the character at index j in word. Then we're going to increment I by 1. So at the end, we're going to check if j equals n. If j equals n, it means that we matched all the characters of word from string s. So it means word is a subsequence of s. Otherwise, it's not. So this function, check subsequence, is actually slower than is subsequence, because this one actually have a early stopping condition. in some sense. So with that said, let me maybe just make a check within this solution. So let's see, check subsequence. So let me use A, B, C, D, E. I'll check if A, C, E is a subsequence of A, B, C, D, E. It should return true, right? So here it returns true. And let's see another one, A, F, E. So it's not. It should return false as expected. So this is another useful small function. So it's actually good to know. So let me comment out this. So overall, the solution is actually very short. So here, here, and here. But notice that if we use this function in this problem, it might get time limited. So as we mentioned, the purpose of this video is to demonstrate the use of the find method, and also we want to demonstrate the small utility function here. So with that said, I guess that's the end of this video. Thank you very much.